Hello everyone, my name is Anson and I'm from Group 7 and this is my group members.
First topic is function. I chose exponential function for this topic, so here is the introduction. An exponential function is a mathematical function in the form of f of x equals to a times b to the power of x, which is a represents the initial value or starting quantity, b is the base of the exponential term, and x is the exponent or variable. An exponential function is a mathematical function used to calculate the exponential growth or decay of a given set of data. Means we can get an exact number for any data, so we can identify whether the data is increasing or decreasing. That's why uh, exponential function is suitable for my case study, which is urban planning, because this function can give an imaginary about the growth of the city to the engineers to plan the structure. Now, case study. An island in Borneo initially had 30,000 people. The government wants to enhance the infrastructure there, which can sustain around 50,000 persons. The island growth rate is 3.2% each year. After 10 years, is the infrastructure still adequate to sustain the residents? Use the exponential function P of t equals to P naught times e to the power of r times t to calculate the island's population after 10 years. Now for the calculation, first thing first, we need to list all of the information given. P naught is 30,000%, growth rate R is 3.2% or 0.032, and time T is 10. Now substitute the information to the formula given, which is P of 10 equals to 30,000 times E to the power of 0.032 times 10. In our study, we use the formula P of T equals P naught times E to the power of RT to project the population growth of an island in Borneo. Starting with an initial population of 30,000 and a 3.2% annual growth rate, we found that after 10 years, the population would be 41,314. This helped us understand the city's growth and confirm that the infrastructure designed for 50,000 residents is still sufficient.
Next, complex numbers. Complex numbers is a fundamental concept in mathematics that extend the realm of real number by introducing the imaginary unit, which is called I, defined as the square root of -1, in the form of a plus bi, where a represents the real part and b represents the imaginary parts. Complex number combine both real and imaginary components. The arithmetic operation for complex number involve the manipulation of these parts, allowing for the representation and analysis of quantities beyond the constraint of real numbers. Complex number is widely employed in various branches of mathematics, physics, and engineering. Complex number also play a crucial role in solving equation, understanding with phenomena, and modeling dynamic systems. Their utility extends beyond the theoretical applications, finding the practical significance in fields ranging from electrical engineering to quantum mechanics. Complex number have been used in various applications nowadays, especially in electrical fields. So for the case study, since there are a lot of ways to analyze the RCL circuit, first year in electrical and engineering students at University Putra Malaysia has been assigned to analyze the RCL circuit by using complex number. In order to analyze the RCL circuit, I suggest you to calculate the impedance and reactance at each component. For example, we started with the inductor component, and the impedance at the inductor given is ZL equal to RL plus J times SL, and then we just need to substitute all the given value and we'll get the answer for impedance at the inductor is 100 ohm plus J times 179.7. And then repeating the same step and at each of the component, and we will get all the impedance value, and then we just need to sum up to get the resultant impedance, where I get the resultant impedance is 200 ohm plus J times 163.8. And to get the magnitude, we just need to use square root imaginary squared plus real part squared, and then we'll get 258.52 ohm. And the phase angle we can determine by using the inverse time formula, inverse time imaginary part divided by real part, and we get the angle is 39.22 degree. Below are the graph for RCS circuit, where the blue indicates the total impedance at each of the component and the purple is the resultant impedance. And on your right graph is showing the graph of phase angle between the voltage and the current. Thus, the total impedance of the RCS circuit is 258.52 ohm. In conclusion, the analysis of electric circuit is very crucial for designing, optimizing, and troubleshooting electrical system, as well for ensuring user safety and reliable operation across various applications and industries.
Hi, my name is Devesh Vincent and my metric number is 225390. Today, I'm going to talk about the application of the application of matrices in heat transfer. Heat transfer is a phenomenon where the heat will be transferred from the hot side to the cold side by passing through a material. The number of heat transfer is determined based on the thickness of material. When the thickness of material is increased, the heat will be reduced. as we can see in this graph. The case study explained that Tenaga Nasional Berhad are planning to build a coal-based power plant at Sepang, Selangor due to high demand of electricity at them. For this power plant, they are required to construct a cooling tower to cool down the steam that produced. The wall of this cooling tower should be at least 1 meter thickness. It is important to ensure the heat transfer in equilibrium by using the given formula. Find the temperature changes inside the wall as passing through from the cooling tower, which is passing through to the open air. As we can see here, the first step we should do is analyze all the value. As we know from the question, the initial temperature and final temperature is already given. So for now, we have to find for the temperature at nodes 2, 3, and 4. For this, we should form an equation for each node. As we should consider that node 2 heat is flowing in. However, at node 3 heat is flowing out. So based on this, we can form a formula as which is negative K times T2 minus T1 over the distance between two nodes. As in the question is already mentioned that the heat should be transferred in equilibrium state. So we can form the equation Q in is equals to Q out, so that we have to equal the both equation, then simplify it to make it as T2 minus T1 equals to T3 minus T2. By using this, we can form equation for all the nodes. As we know, T1 is 1560 Kelvin and T5 is 300 Kelvin. So we have to form the equation for T2, T3, T4 as below. Once we form all the equation, we can rewrite these matrices by putting all the variables. So once we rewrite the matrices will be looks at like this at below. By using Gaussian elimination method, we can found the variable as below, which is T1 is 1560 Kelvin, T2 is 1245 Kelvin, T3 is 930 Kelvin, T4 is 615 Kelvin, T5 is 300 Kelvin. By this, we can conclude that the heat is transferred in equilibrium state because the heat is passing through in equilibrium. Now we are going to see the application of series and sequence in project management. In project management, the triangle of project management is most important. As we know, there is schedule, budget, scope. We should always manage to treat these three in the same, because if we see, when the time of the project is increased, the budget will be increased. When the budget is reduced, the time will be increased. This both will affect the quality, the scope of the project. For the case study, Faculty of Engineering, University Putra Malaysia are planning to change all the surrounding chain link fence into anti-climb fence within 14 days. The perimeter of this faculty is 3,200 meters. After the tender bidding, this project was awarded to Malaysia Engineering with an amount of RM62,000. The engineer of this company, Mr. Arshad, was planned to use 4 semi-skilled manpower to complete this project. Mr. Arshad estimated to install 200 meters of fence per day, and an estimate will cost RM3,000 per day, including wages, material, and consumables. Do they are able to complete this project within 40 days? And how does it cost them to complete this project? Do they make profit from this project? Step 1, we should analyze the value that given in the question. As we know, the AN they give 3200 meter, the initial value is 200 meter and the difference is 200 meter. Now substitute the value into the formula, then we will get the N, which is the number of days to complete this work, which shows as 16 days. Step 3, do the conclusion based on the calculation whether they are able to complete this job within 14 days. Based on Mr. Arshad's estimation, he could not complete this job within 14 days because the calculation shows 16 days for complete this job if he used 4 manpower. Now we need to find the cost of the project. For this, step 4, analyze the value based on the calculation and information. As we know, the number of days is 16, the difference is 3,000 and the initial value is 3,000. Now we have to find the cost of the project. Step 5, substitute the given value into the formula to find the cost. As we substitute, we know the cost of the project is 48,000. Then we do conclusion based on the calculation and justify whether they could make profit from this project. The total cost for this project is 48,000. However, they quoted 62,000, whereas they make profit approximate 14,000 from this project.
So for differentiation, by applying basic differentiation technique, we can find the maximum or minimum point when an equation is provided. Like how? First of all, we need to differentiate the equation and letting it become zero, so we can find the maximum minimum value. In other words, if the equation is area in terms of radius, after we differentiate it and letting it become zero, we can find the maximum or minimum area. When we get the area, we don't know it is maximum or minimum, so we need to do second derivative to identify it. If the second derivative is greater than zero, the area found is minimum area, while the second derivative is smaller than zero, the area found is maximum area. So for the case study, we are required to find the minimum cost to produce part of the submarine prototype and the price is 50 cents per centimeter square, and the volume of the prototype is 144 pi centimeter cube. So for the calculation part, since the question only gives us the volume of the prototype, so we start with the volume of the prototype first. And finally, we get a equation of hash in terms of R, and then we sub this equation into the equation of the total surface area of the prototype, and we get an equation of A in terms of R, then we differentiate it. After we differentiate it, we let it become 0, and finally we get a radius of 6 cm, and sub back to the original equation for the total surface area, and then we get the total surface area for the prototype is 72 pi centimeter square. However, we don't know the area found is maximum area or minimum area, so we need to use second derivative to determine it, and the second derivative is greater than 0. This means that the area found is a minimum area. Then we can find the minimum cost required to produce a prototype. Integration actually a reverse process of differentiation, and it is normally used to find the area and volume of the bounded area in a graph when an equation is provided. So when we want to calculate the area of an object in real life, we can try to apply the object in a graph, and hence we can calculate the area of the object by calculate the area under the graph. So for the case study, the engineering faculty at UPM want to change a new conference room door, and the equation of the new room door is given. Now the task is to find how much space does the renovation worker need to prepare to ensure that the new door can be installed correctly. So for the calculation part, we need to find the coordinate A and B first, and since the equation cut y-axis at point A, so the x-coordinate for point A is equals to 0, and when we sub x equals to 0 back to the equation, we get y equals to x, which is the y-coordinate for point A, and since point A and B are from the same level, they share the same y-coordinate, and when we sub y equals to x in back to the equation, we get x equals to x, which is the coordinate for point B. So to find the space needed so that the new door can be installed correctly, we need to find the area bounded by the x-axis, x equals to 0, x equals to 8, and the equation. Hence, integration is applied, and the space needed is 224 per 3 feet square.